Start. So good evening guys. So in this class we are going to start with the chapter work, energy and power. Okay. Yeah. So before going into the class now, let us discuss the basic of scalars and vectors, and then we will see what are the properties of scalars and vectors also. So before that, the first one, these we have already discussed, but when we are going into the work, energy, power now, we need a basic term of scalars and vectors. So when we discuss about a scalar, scalar is a only magnitude, is it? So vectors and scalar. What is scalar? Only magnitude, no direction for that. When I talk about a vector, it is both magnitude and direction, right? No. So we are talking about a scalar means only numbers will be there. Okay, only numbers will be there. So only magnitude will talk. So only magnitude. When I talk about a vector, both magnitude and direction. Okay, both magnitude and direction. So for example, if we talk about scalars and vector, no, like a basic difference. Okay, so 12 kilometer, we'll say 12 kilometer and 12 kilometer in the east, or any direction will take, some direction in the east or west or whatever it is. Okay. Now when we talk about 12 kilometer, we are particularly talking about the number. Yes, no, the distance we are talking. Right now, when we are talking about 12 kilometer either in north, west, east, south, whatever it is, we are talking about particularly the direction, either front, back, right side or left side. Right now we are talking about direction. So this is the thing we have discussed in straight lines, no, like distance and displacement. When we talk about the distance, it is only magnitude. When I talk about the displacement, both magnitude and direction, like numbers will be calculated in distance. But when I talk about the displacement, in the I should mention the directions also. Right now you can take a note of this. Right now, so we'll go into the scalar products. So scalar product, like vector can be multiplied in two ways. Okay, so one is a dot product, one more is a cross product. We'll see. Right now, when I talk about a scalars, no, I mean a vector, no, when I multiply two vectors, it can be a result. I mean resultant can be either it can scalar or a vector product. Okay, in that we have discussed, no, one is scalar product or dot product. Yes, no, this is a vector product or cross. Like this is a vector, right? Now when I denote with the arrow mark, it will be a vector. When I take a vector dot with another vector, I will get a scalar product. Similarly, I will take a vector A cross with another vector B, I will get a vector product. Okay, cross product and vector product. can take a note of that. Okay, so now we will come to that point. So vector can be multiplied in two ways, a scalar product or a vector product. Scalar product is nothing but a dot product, vector product is nothing but a cross product. So first we will see about a scalar product. Scalar product of any vector is equal to the product of their magnitude and the cosine of the angle between them. Okay, so whatever we are discussing, no, this has been discussed in straight lines, but the basic term we are discussing again. Okay, so when I take A dot B, I will get AB cos theta, right now. When I take A cross B, AB sin theta. Okay, so this is the thing, A dot B, I will get AB cos theta. So A and B is A dot AB is a scalar quantity we will get. Okay, take a note. We will go for the next one. Okay. So properties of a scalar product. So first one is a commutative property and second one is a distributive property. So commutative property is nothing but A dot B will be equals to B dot A. So when I take A dot B, I will get AB cos theta, right now. And if I take B dot A, I will get BA cos theta. Okay. So for commutative property, both the values are same. Okay. So I am taking only numbers, no, like A is 5, B is 10. Okay. A is 5 and B is 10. Okay. Angle between them is 30 degree will take. Okay, or 60 degree, whatever it is. So 1 by 2 will be there. So cos 61 by 2, no. So I will get 25. Similarly, when I do for this one, 10 into 5, 1 by 2 will be equals to again 25. So I am getting the same values. Okay. And next one, if I see for the distributive, so A dot of B plus C will be equals to A dot B plus A dot C. Okay. And if I want angle or a projection, projection of B on A means B cos theta will be equals to B dot A, A dot B by A into magnitude of A. So once we will see the projection also, okay, like when we are discussing about the problem, how to take the projection of B on A or A on B. Okay, no. So next one, for unit vectors. So when we talk about A dot B or B dot A, whatever it is. Now when we talk about I, J, K, no, I will be in X axis, J is Y axis and K is Z axis will take. And when I take I dot I, the result will be 1. J dot J result will be 1, K dot K result will be 1. So when I take I dot minus, the angle is 180. Minus, no, when we talk about a minus, angle will be 180. So 1 into 1 will get 1 only, but 1 into minus 1 minus 1. And when we talk about the minus, no, the angle will be 180. Cos 180 is minus 1. Cos 0 is 1. Okay. Done. We'll go for the next one. Okay. Now the unit vectors, okay, of I dot j, j dot k and k dot I. It will be 0. When I talk about I and j, no, the angle between them is 90°. In the previous case, what is the thing is I cap, again I cap, angle between them is 0°. I cap minus I cap, angle between them is 180°. Okay, when I talk about 0, 1, cos 0, 1, cos 180 minus 1, cos 90, 0. So I dot j will be 0, j dot k will be 0, k dot I will be also 0. If two vectors are perpendicular, when their dot product is 0, and in this case when they are lies in the same, like parallel means angle will be 0, anti-parallel means 180. So 0 is, cos 0 is 1, cos 180 is minus 1. So in this case it is 90 and it is 0. Done? Yeah. Now I am taking a vector A as ax I cap plus ay j cap plus az k cap, and b equals to bx I cap plus by j cap plus bz k cap. When I take a dot product of both them, both of them, no, we'll get a resultant as, see, so ax bx plus by, ay by plus az bz, because when I take this, if I take this and multiply with everything, no, for example 2i plus 3j plus 4k is this A, okay, this one is A, and if I take for B, B will be equals to I plus j plus k. I am doing a dot product for both of them. A dot B is nothing but 2i plus 3j plus 4k dot of I plus j plus k, right? No, when I take 2i and if I multiply with every terms, no, what happens? 2i into I, 2i into j. When I talk about I into j, 0, again I into k, 0, but I into I is 1, yes, no. So 2i into I, right? No, 2i cap into I cap plus again 2i cap j cap, right? No, say when I talk about this term, no, it is 0, right? Yes, no, it is 0. So what is this term? This is ax I cap and this is bx I cap, and when I talk about this ax I plus, I cap by j cap, yes, no, this is bx by bz, this is ax ay az, understood? No, yes. So when I talk about this term, no, it is totally 0, no. So when I talk about ax and bz also, it is 0. So no need to talk about this, like only the term I need is I cap, I into I, j into j, k into k. You can keep in mind simple. So if they are asking for a dot product, do directly and add them, okay. So this is the thing here. So ax bx plus ay by plus az bz, okay. And when we are talking about a dot a, like two same vectors, ax plus ay plus az az. So can we do a problem on this now? Okay. And before that, when they are asking about a magnitude. So magnitude is nothing but, so if suppose ax I cap plus ay z cap plus az k cap they have given for a vector, if they are asking for a magnitude, only magnitude, which means a will be equals to under root of square, again for the square, okay, ax square plus ay square plus az square. Okay, simple term 2i plus 3j plus 4k they have given, and they are asking for magnitude, only magnitude, which means 2 square plus 3 square plus 4 square, which is in the under root. So what will be the answer? 4 plus 9 plus 16 under root. So answer will be root 29. This is my magnitude of A. Okay, this is in the vector form, 2i plus 3j plus 4k, and they are asking for magnitude, only magnitude, root 29 will be my answer. Okay. Now the question is, so A vector is given as 5i cap minus 3j cap plus 2k cap. B vector is given as 7i cap minus 3k cap. Okay, this is my vector, and they are asking for A dot B and magnitude of A dot B. Okay, this is the question. So now what we should do? I should take A vector and B vector and do the dot product. First I will get the answer for this one. Whatever we are getting the answer, I will take the magnitude of that. I will get for the second one. Okay. So what I will do? Okay. Now 5i minus 3j plus 2k dot 7i minus 3k. What I told? Take I cap, multiply with I cap, get the answer. So 5, 7, 35. J is there, J is not there now, so I can assume it as 0. So 3 into 0 something? 0 only, no? Yeah. So plus 0, 2 into minus 3? Minus 6. So answer is 29, no? That's it. So answer will be A dot B will be equals to 29. That's it. Got it? Yeah. Now can you give magnitude of this A and B separately? What will be the magnitude? So magnitude is nothing but under root of 5 square plus 3 square plus 2 square, which is nothing but 25 plus 9 plus 4, 34 plus 4, 38, right now? Okay. For this one, root over 49 plus 9, which is nothing but 58. That's it. Okay, this is the magnitude of A separately and B separately. Okay. Now we'll come for the work. So now we have completed the basic properties of scalars, okay, and what is the properties, so like what is commutative property, what is distributive property, and how we can multiply the scalars. Okay. Now work is nothing but it's defined as the product of component of force in the direction of the displacement and the magnitude of the displacement. Suppose there is a remote, there is a remote on the surface. I am applying a force on this. What happens? Is this remote is moving? No, it's in the same position. Yes, no? Since I am applying force also, it is not moving. The thing what we should understand is, like when force is acting, a displacement should taken place. okay, then only a work has been done. Yes or no? So if your mom is saying to get something from supermarket, you will walk and you will go to the supermarket and you will get the groceries whatever you need, your mom asked, and you will come back. You walked and you took something and you are coming back. So you have done some work there. Okay. If you simply sitting there, okay, mom, I'll go, will it come? The grocery will come? No, right? You should apply some force. Yes, no? And then you should go there and you should get that product and you should come back. Like displacement is happening, no? So whatever the forces are there, like if I apply force also, there should be some displacement over there. Then only the work will be taken place. Yes, no? If I apply a force perpendicularly, there is no work. But if I make some angle, no? If I push like this, it will go. Yes or no? If I pull like this, it will come. So I am applying some force, but at particular angle I should do it. Yes, no? So it is the work is nothing but it's the product of force and displacement. Okay. So F dot D. So Fd cos theta is the one more formula. Okay. So when we talk about work, it's a product of both force and displacement. So the formula is W equals to F dot D. The another formula is Fd cos theta. Okay, where F is force and D is displacement. So the unit will be Newton meter or joules. For force it is Newton, for displacement it is meter. So Newton meter or joules. So dimensional formula ml square t power minus 2. Done? Okay. So positive work and negative work. And one more type is zero work. Okay. When we talk about a zero work, when object is there, okay, object is there. If I apply a force like this perpendicularly, so the angle between them will be 90 degree. Cos 90 is 0. So work done will be 0. So positive work is nothing but angle will be between 0 and 90. So it is a positive work. Negative work is nothing but angle between 90 to 180. It is negative work. Okay. And 0 work means angle is exactly perpendicular. Okay. So work done by external force F. So W will be Fd. Okay, cos 0 is 1. When I talk about a cos 180 is minus 1, no? Yes, no? So minus force into displacement, this is force into displacement. And for this one it is exactly 90 degree. Cos 90 is 0. Okay? Done? Write the notes properly, okay? Done. Can you go for the next one? Okay. So you have taken this one no. So when angle is 90 degree, the work done will be 0. Okay. So condition for no work done. So displacement is 0 or else force should be 0. Okay. So displacement is 0 when I am applying a force. Okay, I am applying a force. Is the wall is moving? Like I am applying a force on the wall. Will the wall move? No. How I am applying the force? I am applying a force like this. Okay, but it is in the 90 degree, and if it is 90 degree also the wall is not moving, right? So there is no displacement. So there is two conditions. One, there will be no displacement, and another will be force will be equals to 0. Okay, so these are the two conditions when we talk about no work done. Okay. Can we see the third condition now? Okay. So the third condition is the force and displacement are mutually perpendicular. So the first condition, what they are saying? Displacement is 0. So no, there is no work done. Second condition, force is 0. So no work done. Yes, no. So W equals to Fd cos theta. Either force should be 0 for work done to be 0. Second one, displacement should be 0 for work done should be 0, or else the angle between them will be 90 degree. Yes, no? So totally 3 conditions. First 2 conditions we have seen, and the third condition is the force and displacement are mutually perpendicular, which means theta is 90, cos 90 will be 0. Okay, take it. So when we are talking about a particularly circular motion, no, circular motion means like when I start rotating with a rope object, no, it will be in a circular path. Okay, so when I am rotating, a force will be inside and displacement will be towards out now. So angle between them will be 90 degrees. So there is no work done for the circular motion. Okay. So with this we will stop the class, okay, and we will continue with the upcoming problems in the next class. Okay. Okay guys, thank you. We will see in the next class.